The first problem on the study guide, Don made the trip in 12 hours. Hazel drove 10 miles per hour faster than Don, so she made the trip in only 10 hours. How many miles long was the trip? First thing I'm going to focus on in these problems always is the distance. They have no mention of distance, but they're talking about a trip. Don made the trip, she made the trip, so that's implying to me the trips are the same distance. So what I would do first is make my relationship of distances as Don's distance is equal to Hazel's distance, seeing as they made the same trip. At this point, once we've established how the distances relate to each other, now we start getting our chart, as we usually do. So Don and Hazel are the people driving in the problem. And we can see right off the bat, Don made the trip in 12 hours, so his time of travel is 12 hours. Hazel made the trip in only 10 hours, so her time is 10 hours. So I like to focus on one thing at a time here, so the time of both are both given. They don't tell me how fast either person drives, but they do tell me that Hazel drove 10 miles per hour faster than Don. So if Don's going at whatever speed he's going, we'll call it R. Her speed is 10 miles per hour faster. Faster is an addition, so R plus 10 would be her speed. The other way to handle that would make her speed R and his speed R minus 10. I prefer to stay away from subtraction if I can avoid it, so this is probably better. And at this point, once we know both their rates and their times using at most one variable, it's rate times time is equal to distance. So multiply rate times time makes 12R for Don's distance, and R plus 10 is a binomial, times 10 makes 10R plus 100 for her distance. We've already established their distances are equal, so we take their distance expressions, which are these guys, set them equal to each other, because that's the relationship in this specific problem. And solve for R in this case, so minus 10R goes over here. That needs to be 2R is equal to 100. Therefore, R would have to equal 50. And R, going back to what R represents, it's Don's rate. The question specifically asks us how many miles long was the trip. And on the test, we're going to have Don and Hazel driving. You're going to be asked how many miles long the trip was. So make sure you answer the question they're asking. How many miles long is a question of distance, specifically Don's or Hazel's, since they went the same distance. I'm going to go with Don's. So if I do 12 times 50, that makes 600 miles. Had I done Hazel, 10 times 50 plus 100, it's interesting. It makes 500 plus 100 makes 600 miles. So take your pick. If the distances are equal, which they will be on the test, you can go with either one. That's easier in my book. You just have to do one multiplication. You have to multiply and add here. But make sure you answer the question. A lot of you are getting to this point and stopping. Make sure that you answer the question. That's always the final step in these problems. Problem 2. Brett and Julie headed north at 8 a.m. By noon, Brett was 100 miles ahead of Julie. So again, if I'm focusing specifically on distance here, Brett was 100 miles ahead of Julie. Brett and Julie headed north. Okay? They don't specify anything about their starting positions. I'm going to assume they're in the same starting position. So if I make their starting position here, we'll put Julie right here and Brett right here. And Julie went some distance, Brett went some distance. I can see Brett went more distance. So if I make Julie's distance right there, Brett's going to go further. So that will be the ending position of Brett. This is the ending position of Julie. And the discrepancy in their distances, what they told us this is 100 miles. They did not tell me how far Julie went, so I'm going to put D sub J to represent her distance. They didn't tell me how far Brett went, so D sub B is going to be his distance. And just like that, I can see the picture. Short plus short equals long, so D sub J plus 100 is equal to D sub B. So that's the relationship of distances in this problem. And again, that's priority one of these problems always. Get the distance relationship first, then we can use that to create an equation once we know what the distance expressions are. To get distance expressions, we come back over here. Our categories are going to be Julie and Brett. Great time and distance up there. First off, what was Brett's speed? It means we don't know Brett's speed. If Julie's speed was 50 miles per hour, we do know her speed. So her speed is exactly 50. his speed's unknown. The fact we had to use an unknown for the rate tells me the time should be known. And what you have to be careful of with this is time is elapsed time. 8 a.m. is when they started. It says by noon. Noon is 12 p.m. That's a total of 4 hours. Be careful that sometimes you use the words to represent times, noon, midnight, that kind of thing. Make sure you make an understanding of what that is. So 8 a.m. up till noon is 4 hours. And again, time is always elapsed time. I see a lot of people want to put 8 because it says 8 a.m. It's a time. But again, this is how much time passed, not what time it says on the clock. So 8 a.m. to noon is a 4-hour time. They started at the same time, and at noon they ended at the same time, so their times are both 4. Which gets me Julie's distance be exactly 200 miles. Brett's distance is only 4 r miles, or exactly 4 r. And at this point, if we substitute the numbers over there, we should get what everything is. So Julie's distance, which is here, is 200 plus 100 is equal to Brett's distance, which is 4r. So again, once we establish what their distances are, we can just substitute them into the expression. R is the only variable here, so 300 is equal to 4r. Divide both sides by 4. We find out that Brett was going 75. The unit of speed is miles per hour. What was Brett's speed is the question. R is Brett's speed, so that answers the question. Again, that happens sometimes. Sometimes you have to modify your answer some. So in this case, that's the exact answer. That's where we'd be done. Number 3, find x if the perimeter of the quadrilateral is 40 inches. The trick to this problem, what you have to remember to do this problem, and hopefully if you watch this video you'll remember it, is that if you have 2 tangents drawn to the same circle, they're equal. So this piece here and this piece here are the same length. So this piece here is x minus 1, and C, which also would equal x minus 1, getting one variable to represent 2 different things rather than using 2 different variables to represent the thing. So these are the same values, so we get them both in terms of x. We're going to do that with all these pieces. So the next thing I'm looking at is this piece and that piece. So this is tangent, and that's tangent. Those 2 pieces should be the same. And we can see that our choices are a and 2x. This has an x in it, so that's better. So I'm going to throw out a, and I'm going to put 2x in place of a. I'm going to do that the same for each of these objects. So the next thing I'm going to look at here is the piece here, which is tangent, and the piece here, which is tangent. And we can see the pieces are x plus 3, which is about x, and then b, which isn't as good as x plus 3. And then finally, I'll keep this last part black. That little piece and that little piece are the same. Our choices are x over 2 and d. This is about x, this isn't, so I'm going to change that d to an x over 2. So on the test, you can expect that to happen. You can have this quadrilateral, we got all these tangents. These 2 pieces together make up that side, these 2 make up that side, these 2 make up that side, and these 2 make up that side. And they tell me, in the problem, the perimeter of the quadrilateral is 40 inches. So if I add up all the stuff I'm looking at, both blues, both reds, both greens, and both blacks, that should add up to 40 inches because that makes up the whole figure. So that's exactly what I'm going to do. I'm going to do x over 2 plus x over 2 plus x plus 3 plus x plus 3 plus 2x plus 2x plus x minus 1 plus x minus 1. All that together, all that together equals the perimeter, which is 40 inches. Again, 40 is not a magic number, it's just what they told me the perimeter was. So that's where the 40 came from. At this point, I've got a bunch of terms. I look for like terms. X over 2, x over 2, x, x, 2x, 2x, x, x. All those are like terms. If I add all those up, x over 2 plus x over 2 makes 1x, 2x, 3x, 5x, 7x, 8x, 9x all together for the x's. The numbers are 3, 3, minus 1, minus 1. So 6 minus 2 is going to be 4. And 9x plus 4 equals 40. Move the 4 over, so 9x is equal to 36. We divide by 9, we get x equals 4. It says find x, found x, end of problem. So again, on the test, expect it to be that shape, not necessarily the exact same shape. It'll be a circle inside a quadrilateral. The tangents are equal. Get everything in terms of x to create a good equation equal to the perimeter. solve that equation to get x. Number 4, simplify, and our job is to, you can see here we're multiplying two rational expressions, a bunch of quadratic trinomials. So I've got x squared minus 2x minus 3. Negative 3 times 1, negative 3 plus 1, so x minus 3x plus 1. X squared plus 2x minus 8, parentheses, parentheses. 4 times negative 2, 4 plus negative 2, so x plus 4x minus 2. Then it says times, so it's going to be fine. If it was a division, we have to change the multiplication. This one is multiplication, we're ready to go. The top here, 4 times 5 is 24, plus 5 is 9, so x plus 4x plus 5. And finally the last one, x squared plus 6x plus 5. 5 times 1 is 5, 5 plus 1 is 6, so x plus 5 times x plus 1. And once you've done all the factoring, then you're looking for the same thing to happen on top and bottom. X plus 1 is the same as x plus 1, they cancel. X plus 5 is the same as x plus 5. X plus 4 and x plus 4. The leftover piece on top, x minus 3, does not match the leftover piece on the bottom, x minus 2. So your final answer is that. You should expect on this test, problem like that, I'm going to make everything cancel except for one thing, so expect an answer like that. If you get multiple pieces that don't cancel, chances are you factored improperly. So just pay attention going from here to here correctly, and then cancel all the things that are exactly the same. Number 5, same kind of problem. The slight difference here, this is divided by instead of times, so be watching for that. So once again, we have all quadratic trinomials, so it's a matter of factoring each one individually. So that's going to be x minus 1 and x minus 2, verifying. Negative 1 and negative 2 multiply to make positive 2. Negative 1, negative 2 add to make negative 3. X squared minus 2x minus 3. Negative 3 times 1, negative 3 plus 1, so x minus 3, x plus 1. And notice none of those match, so hopefully some of the stuff over here will match. Next one, I'm going to change this to times. And because I change that to times, the bottom becomes the top of this one, and the top of this one becomes the bottom. So we're flipping that one over. If you're comfortable flipping and factoring at the same time, that's fine. If you feel more comfortable flipping first, then factoring, rewrite the problem correctly and then factor. Whatever you're more comfortable with is what I would do. Positive 12, negative 7, that would be negative 3, negative 4. So x minus 3, x minus 4. Those multiply to make the positive 12, they add to make the negative 7. That goes on top again because it was on the bottom. We changed division to multiplication. X squared minus 6x plus 8, negative 2, negative 4, negative 2 plus negative 4, so x minus 2, x minus 4. Again, that's the top. We flipped it, so now it's the bottom. Once you get everything factored completely, again, it's a matter of canceling things that are the same. This matches this. X minus 3 matches x minus 3. X minus 2 matches x minus 2. What's left on top is x minus 1, on bottom x plus 1. Again, on this specific test, you can expect that to happen again. So everything should cancel except for one thing on top and bottom. If it doesn't, you factored wrong, or maybe you forgot to flip something over. If you didn't flip this over, these will both be on top, these will both be on bottom, then you wouldn't get some cancellation. So make sure you do it all properly, factor everything properly. All that cancellation should happen, leaving you with this nice, friendly answer. Number 6, negative 4 to the negative 3 halves power. So anytime you deal with a power, you have to ask yourself, what's being raised to the power? That helps you establish where things belong. So what's being raised to the power here is only the 4, because there's no parentheses involved. The minus sign is not being raised to the power. The fact that it's a negative power, I don't care about fractional power before I deal with the negative power situation. So minus is minus, it's staying right where it's at. Everything, it's a whole number structure, so that's everything in the numerator. All this stuff highlighted belongs in the denominator. Once it goes where it belongs, the negative power switches to a positive power. I can't have a fraction with no numerator, so I'm going to put a 1 on top just to have a numerator. So negative 1 over 4 to the 3 halves power. That's job 1, fix the power sign. Job 2 is to evaluate 4 to the 3 halves power. That's a 2-step process. I'm going to do it in 2 steps here. I usually just do it all, but the bottom number is a root, the top number is a power. You do it in that order. Root first, power second. So the square root of 4 is equal to 2. Once I do the square root of 4, that denominator goes away. So now it's 2 cubed. Then I'm supposed to evaluate 2 cubed. 2 cubed is equal to 8. I'm expecting you to get all the way to that point there. If you don't get there, if you get to here, I might give you half credit for applying the negative power rule correctly, but I'm expecting you to evaluate this. It will come out to a nice friendly answer like that. It won't come out to some decimal. So make sure that you, again, the bottom number is a root. You take the root. Once you've taken the root, now it's not a fraction of power anymore, it's just the numerator. And whatever this is to that power, 2 times 2 is 4 times 2 is 8. And then again, the 1 on top, no, minus 1 on top just comes along to the right because it's nothing happening to it. Number 7, simplify. We got a complex fraction. I can see very clearly that this is a fraction, and this is a fraction, and I've got a main fraction bar happening right here. So I don't want 2 over x and 3 over x to be in my problem. Fractions inside of fractions is not simplified. So my task is to identify all the terms, whether they're fractions or not. Focusing specifically on the fractions, I find the least common denominator of the fractions identified. So 4 is not a fraction, 5 is not a fraction. They don't matter in this decision. Only these two things matter. And the common denominator of these two things is just x. So if I do times x, times x, times x, times x, all the fractions will disappear and I'll be left with the best answer possible. Every x I'm multiplying is a whole number structure x, so it's a numerator and the over x is a denominator in each case. So x cancels x here, leaving me with 2. Nothing cancels here, leaving me with 4x. And be careful, that says minus, it's going to be minus 4x. Down here, this x numerator, this x denominator, those cancel, leaving me with just the 3. And then this 5 times x is 5x. And notice again, this is a plus sign, so I put a plus there. I've seen a lot of people get these wrong because they put the wrong sign. They'll put a plus where it's supposed to be minus or vice versa. So the structure that we have, positive, negative, positive, 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 negative, positive, positive, not being affected by what we do, it should remain the same. Non-fractions just get bigger. 4 times x is 4x, 5 times x is 5x. Fractions cancel, leaving you just with numerators. And then there might be some leftover stuff you have to multiply by yet, but that's kind of what I'm looking for in that problem. Number 8, simplify this. What I want you to do is evaluate this. If we do it with scientific notation, 3,000 times 10 to the 8th power is 3 times 10 to the 11th power. Okay, if we just consider that, we're moving this decimal point 3 spaces right, making it smaller, so we have to add 3 to our power. So 8 plus 3 is equal to 11. Our next number is 400 times 10 to the negative 19th. Okay, we're going to change 400 to 4. That's 2 decimal place move, making it smaller, so we have to add 2 to this. Negative 19 plus 2 is negative 17. I do recommend writing it out just like this. 8 plus 3 is 11, negative 19 plus 2. If you can actually visually see what you're doing, you know whether to add or subtract. These are the same sign I added. These are different signs, so I subtract. Even though it's a plus 2, I'm adding 2 to a negative, so subtraction is actually what I end up doing for that. On the bottom, we've got this, so I got 6. And again, I got to figure out what power. 1, 2, 3, 4, 5 spaces made it bigger by 5, so I have to take 5 away from this. That makes negative 16. And at this point, I just multiply it out. So 3 times 4 is 12. And 11 plus negative 17 is negative 6. Down here I have 6 times 10 to the negative 16th. And nothing happened on the bottom, so that's fine. On the top, what I did to multiply was 3 times 4 made the 12, the new abscissa. And the power of 10, I'm adding the powers of 10 that I have here. 11 plus negative 17. Again, adding algebraically, the signs are different, so I actually subtract the numbers. 17 is bigger, so it's negative. The final step is to divide, and I make a decision here whether or not I want to change this top to good scientific notation or not. I look at this division problem and ask myself, is it easy or hard? 12 divided by 6 equals 2, I'm not going to mess with it. All right. If it was something more challenging, let's say it's 6 over 12, maybe at that point I want to change good scientific notation, whatever. But 12 over 6 equals 2. All right. The place where most people mess up is right here. It's real simple what we're supposed to do. The rule says you take the top power, which is negative 6, and subtract the bottom power, which is negative 16. That's what the rule says. People hear the word subtract, and then they think subtract, or sometimes add, sometimes subtract. I don't know what I'm supposed to do. So if you can actually visually look at what you're supposed to do, top minus bottom, plus, plus, because minus and minus makes a plus. The signs are opposite, so I actually do subtract. 16 minus 6 equals 10. This 16 is positive, which is bigger, so it's positive 10. Okay? If you write that down on your paper, the chance of getting it right has increased hundreds of times. So be careful that you actually do that and get the right answer that way. Number 9, simplify 4 square root of 2 fifths minus 2 square root of 5 halves. Quite a few of you are getting these wrong on homework. Most of the reason we're getting them wrong is we're not taking them far enough. A few of us are having some issues on how to actually simplify each term. So let me focus on the simplified terms first. This first term, 4 times the square root of a fraction, becomes 4 on top times the square root of 2 on top over the square root of 5 on the bottom. Whatever the fraction is, the numerator goes on the numerator, the denominator goes on the denominator, separated into 2 radicals, this one and this one. This one's okay, this one's a problem. We don't want radicals in the denominator. So the issue, as far as simplifying is concerned, the issue is we don't want radicals in the bottom, so that's the problem. Square root of 2 on top I don't really care about. It can be a square root of anything, I don't care. I'm going to leave myself a little bit of space. The second fraction, the second term is minus 2 square root of 5 halves. So I'm going to do a little space, minus goes with this term. 2 is in the numerator because it's a whole number. Square root of 5 belongs in the numerator because it is. Square root of 2 belongs in the denominator because it is. So again, separating those radicals, that's priority 1. Get the problem simpler in that manner. You don't want square roots of fraction, you want square roots of whole numbers, just one on top, one on bottom. The first fraction, the issue is the square root on the bottom. We don't ever want that, and fixing a square root on the bottom is simply multiplying by the exact same square root. This times this equals 5, radicals go away. Fraction world, the bottom gets multiplied, you multiply the top. So altogether, this blue term, if I multiply it out on top, 4 is outside the radical, 2 times 5 makes 10 inside the radical, square root times itself makes the number without the square root symbol. So that's how the term gets simplified. And again, that's the requirement. I see this, whatever this is, that's what I multiply top and bottom by. 5 and 2 in a radical, 5 times itself makes just 5. Same thing on the red one. The issue is the square root of 2 on the bottom, so the fix is the square root of 2. Square root of 2 times itself makes 2, which is what I'm looking for on the bottom, a nice, pretty whole number. I got to multiply the top by the exact same thing. That's the requirement of fractions. 2 outside. Square root of 5 times the square root of 2 makes the square root of 10. Square root of 2 times itself makes 2. It just so happens that these reduce. You're allowed to. Not required to, but you're allowed to. So those cancel, so I just get minus the square root of 10. Officially over 1. If I'm dealing with fractions, I prefer to have fractions on everything. Okay, looking at the fractions I'm looking at, the last step, and this is where a lot of you are stopping, and again, this is the other place people are getting homework problems wrong. You're doing all this stuff perfectly fine, but then to stop here, that's an issue. So 4 fifths is being subtracted by 1. All right, the common denominator would be 5, so times 5 on the bottom times 5 on top makes the common denominator 5. So I end up with 4 times the square root of 10 over 5 being subtracted by 5 times the square root of 10 over 5. Since the radicals match, which they will, we can subtract. 4 minus 5 on top makes minus 1 times the square root of 10 over the common denominator of 5. That's where I'd expect you to finish. The 1 here is not required. If you didn't put it there, it's not wrong. Usually it doesn't come out to 1s, but if it does, that's how you handle it. If you want to put the 1, it's fine. If you don't want to put the 1, it's fine. It does have to be negative, though, because 5 is bigger than 4. Okay. That's where I expect you to give your answer to, down to that point. Had we gone all the way back to this point here and not noticed that those 2's cancel, at this point the common denominator is 10, so this needs a times 2, this needs a times 2, this needs a times 5, this needs a times 5. If we did that, that gets me 8 times the square root of 10 over 10. This gets me minus 10 times the square root of 10 over 10. Again, we're still at the same point. We have a common denominator of 10. 8 minus 10 makes negative 2 times the square root of 10, which again, subtraction's legal because they're both square roots of 10. And that's the right answer, but notice that negative 2/10 reduces by 2 down to negative 1/5. So again, you get down to that simplest form. Outside the radical, you're allowed to do things like normal. Inside the radical, you get what you get. So once you get 10s here, it just stays square root of 10 all the way through. The outside numbers are what create the rest of the answer. So That's the problem. That's where I'm trying to get you to. If you don't get me all the way to this point, you won't get full credit. If you get me down to this point, I might give you half credit. I'm not going to guarantee it, but just add the fractions, subtract the fractions, depending on size. Number 10, simplify. And again, we have a radical times radicals. This is a distributive property situation. So outside the radical, outside the parentheses, I have 3 times the square root of 12. Inside, I've got 2 times the square root of 3 and negative 3 times the square root of 2. And in order to multiply this out, I need to do this product and I need to do this product. When I multiply the black, so the blue times the black, the whole number multiplies by the whole number outside. So 3 times 2 makes 6. Inside the square root, though, instead of multiplying 12 times 3 to get 36, I want to break it down more. 12 is 2 times 2 times 3. If you can do that mentally, fine. If you need a factor tree, fine. But if you verify that, 2 times 2 is 4 times 3 is 12. You can see 12 is the same as that. And then the black radical we have times 3. Okay, so now it's in prime form. Everything's prime, so that's good. All right, then I do the green multiplication. 3 times negative 3 is negative 9. I'm going to put a minus sign here, but then I'm going to leave some space. So there's usually some numbers being pulled out, so leave some space to account for that. But minus, because again, 3 times negative 3 is minus, and then 3 times 3, of course, is 9. Then we have a square root symbol again. Should be green, I suppose. Alright, and again, this number 12 is still 2 times 2 times 3. And this green number in here is 2, which is prime. So again, the black 3 is prime, the green 2 is prime. The primes are already there, but the blue number 12 breaks down to 2 times 2 times 3 in both cases. That's how you want to multiply. The whole number is whatever it is. 3 times 2 is 6, 3 times 3 is 9. That's fine. Inside you want to break down. The reason we break down is because specifically we can take out pairs. So a pair of 2's gets to be a 2. A pair of 3's gets to be a 3. A pair of 2's gets to be a 2. A 3 and a 2 aren't pairs, so they have to stay in. So any pairs get to come out. Every pair gets to come out as one number. So 2 times 2 is 4, square root of 4 is 2. 3 times 3 is 9, the square root of 9 is 3. You can take out square roots in pieces like that. That's legal. And the final result of the black term, 3 times 2 is 6 times 6 is 36. Square root of nothing, so the square root's just gone. For the green term, minus 2 times 9 is minus 18. And inside the square root, since we have stuff left over, 3 times 2 is 6. This is a whole number. This has a square root attached to it. Subtraction's not legal. So that's the final answer, the best you can possibly do to it. If these don't subtract, these won't subtract. So make sure that you keep that in mind. And again, if everything disappears from the radical, just leave the radical off. If stuff is left in the radical, multiply the stuff back together. So a single number outside, square root of a single number inside, is just a single number outside because the inside number is gone. Number 11. Adding algebraic fractions, and we can see we have a quadratic trinomial. In general, if you start seeing x squared in a polynomial, look for factoring possibilities. So, 4, let me put this fraction here in red, this fraction, 4 is over x to the second. That's not in a polynomial, that's just x squared. I can't make that any prettier. I can make it xx if you wish, but it's not really going to help anything. Times x minus 2. And then we'll do the second fraction in blue. We are subtracting, so it is minus. I'll leave myself a little space here. So minus, and then I've got 3 on top. And if I factor x squared minus 3x plus 2, that's going to be x minus 2 times x minus 1. Okay, so that's priority 1. Factor everything completely. So you're looking at the denominators all in factored form. And then what we're looking for is commonality. So this has an x minus 2 attached to it. This has an x minus 2 attached to it, so that's already common. That's in both denominators, so that's already been taken care of. The red fraction has an x squared that the blue fraction doesn't have. The blue fraction has an x minus 1 that the red fraction doesn't have. So that's what I need to fix. So I want the red fraction to get an x squared on it. So I need an x squared on the bottom. I have to put an x squared on top to account for that. Now if you take a look at what's common, and again, this wasn't here so I had to put one on top also, but now if we're still comparing stuff, those are now the same. So that's good. Finally, this has an x minus 1 that's missing, so I need an x minus 1 on this. If I want to put one on the bottom, I've got to put one on top. And now, if we're, again, comparing fraction denominators, this has an x minus 1, this has an x minus 1. Now they're exactly the same. So you have to modify the bottom In order to do that, you have to modify the top also. Once you've modified, though, now comparing, they're exactly the same. So now we're to a point where we have a fraction that can be combined into one fraction. So we've got one fraction, the denominator that matches is x squared times x minus 2 times x minus 1. Then we simplify as much as possible. Anytime you multiply by a binomial, you're multiplying in parentheses. So distributive property here, that gets me 4x minus 4 for the top. Subtracting 3x squared, I like descending order, so negative 3x squared first, positive 4x second, minus 4 last, all over my common denominator of x squared times x minus 2 times x minus 1. I'm looking for the top to be completely simplified. The bottom can stay in factored form. That would be the answer to that problem. Okay. If for some reason you find it necessary to take this times this times this as a common denominator, making this big, ginormous denominator, I'll give you half credit if you get the right answer, only because you're going to cause me an extra 2 minutes to do it myself, and I don't want to have to do that. So this is how I expect you to do it. It will be factorable, factor it, there will be a common factor. Expect that to happen. If you, again, just do this times this times this as a common denominator, it's not wrong, it's just a lot uglier than it has to be. So that's how I expect you to get it for full credit. Number 12, solve. And the key to this problem, and the place where people are messing up on homework, is right here. It looks pretty innocuous. It doesn't look any much more difficult than anything else happening in the problem. That minus sign in front of the fraction knows what's going to cause issues. So what my typical advice on this problem is to separate this fraction and this fraction into pieces. So 2x minus 5 over 3 is the same as 2x over 3 minus 5 over 3. And it's just a positive thing there, so the signs are what they are. 2 over 3 is positive, 5 over 3 is negative. Then I have minus x over 4, which is just behaving itself, being a regular single fraction, so just bring it along for the ride. Now here's the place where people mess up if you're not being careful. So minus x over 6 and minus 4 over 6 makes plus 4 over 6. That sign's positive because this minus sign is not just touching the x, it's also touching the negative 4. Minus makes a plus. Be careful of that. It will happen on the same problem on the test, just like that. So, get everything into a single fraction. Every dual numerator fraction just becomes separate fractions, each over the denominator. This over this, this over this. But again, that minus sign will distribute through, making that fifth term a positive. At this point, looking at the fractions, the denominators are 3, 4, and 6. My least common denominator for those numbers is 12. 12 evenly divides by all numbers, 3, 4, and 6. I can go with 24, 36, 48, 60. Any multiple of 12 will also work. 12 is the least common denominator, makes the numbers the smallest possible, so it's the best to use. Divide, then multiply. So 12 divided by 3 is 4 times 2x is 8x. 12 divided by 3 is 4 times negative 5 is negative 20. 12 divided by 4 is 3 times minus x is minus 3x. 12 divided by 6 is 2 times minus x is minus 2x. 12 divided by 6 is 2 times 4 is plus 8, and 12 divided by 4 is 3 times negative 1 is negative 3. It shouldn't take much longer than that for you guys to multiply by least common denominator. If it doesn't divide evenly, you have the wrong number over here. So the number divided by 3, 4, and 6 perfectly well. The result of the division multiplies by the top, in each case getting you the non-fraction problem. At this point, I got a bunch of x's on the left, so I'm going to move the minus 20 and the plus 8 to the other side. Minus 20 moves over as a plus, and plus 8 moves over as a minus. This, and this, 8 minus 3 minus 2 makes positive 3x. 8 minus 3 is 5, 5 minus 2 is 3. Equals, and on the right side, 20 minus 11 is equal to 9. And if 3x equals 9, that means x equals 3. I would expect that problem on the test to come out to a nice, pretty non-integer, a non-fraction answer. So something like that. If you get a fraction, chances are you messed up. Probably right there. If that said minus 8, this would say plus 8. 28 plus 3 is 25. Divided by 3 doesn't come out evenly. So that's more than likely what you did wrong if you mess up. The other possibility is maybe you did some calculation errors going from here to here. So be careful of that. Number 13, solve. Notice we have powers. Once again, powers happen. We have to ask ourselves what's being raised to the power. That's the first step in this problem, is to deal with those powers. So 4x to the 0, x is being raised to 0, the 4 isn't. 5 to the 0, the minus sign is not being raised to the 0 power. Same thing here, minus sign is not being raised to the power. So that's what I do first, is deal with those. 4 times 1 is 4. So that whole thing just becomes 4. Then I got a minus 3 that's behaving itself, being multiplied by x, and a minus sign behaving themselves. This 5 to the 0 also equals 1. Okay. This one's being multiplied by 4, which makes 4. This one's being subtracted, so that 1 is a necessary one. Be careful of that. So when you have a 0 power, don't just start crossing stuff off. Ask yourself, is it important or not? Times 1 doesn't matter. Minus or plus 1 does matter. So make sure that that stays minus 1. I got minus the absolute value of negative 5 minus 8. We'll deal with that next. Equals 3x times 4 minus 5 to the 0 power. Again, it's 4 minus 1. Minus 1 matters. Minus 10x. So if we deal with all the 0 powers, we get ourselves to this point. What's in blue is what the 0 power stuff ended up creating. Next, distributive property. To get rid of parentheses, I'm also going to deal with my absolute value expression. So I'm going to do a distributive property here. I'll do a distributive property here. Actually, I'm not going to do distributive property there. Change my mind. 4 minus 1 makes 3. Now it's just 3x times 3. So I'll evaluate that, and then I'm also going to work with that. So that's what I'm doing next. So everything that stays the same is going to go in black. So 4 is staying 4. Distributive property, negative 3 times x is negative 3x. Negative 3 times negative 1 makes positive 3. Be careful. Anytime you distribute, the number and the sign are being distributed. Minus times minus makes a plus. We got minus absolute value, which I'm going to continue to be an absolute value until I evaluate it. Negative 5 minus 8 is negative 13. Signs are the same, so I add. Equals 3x times 3 is 9x. That would have been the same as 12x minus 3x. Also makes 9x. Take your pick how you want to handle it. If they're both numbers, I would evaluate, then multiply, but again, it's up to you. Decide how you do it. Either way, you're going to get the same result for that piece. What's left to do? I'm going to combine some like terms. Let me deal with the absolute value real quick. The absolute value of negative 13 is 13. That did not affect that minus sign. So now that was positive 13 because of the bars. Now it's a minus 13 because of the minus sign. So altogether on the left-hand side, I got negative 3x. And I've got 4 plus 3 minus 13. So that's 7 minus 13 is negative 6. Equals. On the right-hand side, I've got 9x minus 10x makes negative 1x. There's no numbers. So all this I have to do is get my x to one side. I'm going to move the 3x over here. That gets me negative 6 on the left is equal to positive 2x on the right. Since x is being multiplied by 2, we divide both sides by 2. That gets me x equals negative 3. Once again, an integer answer on that one. I would expect probably on the test, integer answer on that problem. Number 14, divide x to the 4th minus 1 by x plus 2. We're dividing by x plus or minus a number, so it has the right structure to use synthetic division. I would recommend doing that. Synthetic division always starts with this number in the box, which is opposite of that number. So negative 2 is the opposite of that. The question you're asking yourself is what makes that equal 0? Negative 2 plus 2 makes 0, so negative 2 goes over here. And then what goes over next to this are the coefficients of this, accounting for every power of x in the process. So it's 1x to the 4th. X to the 4th is there, so x cubed, x squared, x and constant have to be accounted for. 1x to the 4th, there is 0x cubed, there is 0x squared, there is 0x to the 1st, and there's a minus 1. So every power of x is accounted for. 4th, 3rd, 2nd, 1st, constant. 4th and constant both had a numerical value. The other three didn't, so we put zeros in their places. You leave yourself a space here, draw a line there. First number comes straight down. Whatever it is the same always. And then every next number up is multiplying the bottom number times the box number. So 1 times negative 2 is negative 2. Add, you get negative 2. Negative 2 times negative 2 is positive 4. Add, you get positive 4. Negative 2 times positive 4 is negative 8. Add, you get negative 8. Negative 2 times negative 8 is positive 16. Add, in this case subtract because the signs are different, you get positive 15. Okay. The addition, each time the green and the black to add is dependent upon signs. Adding 0 just doesn't change any numbers. Once you get to this point, you actually have a number. These signs are different, so I actually subtract, and then 16 is bigger, so it's positive. The box, the last number here represents the remainder. Constant x, x squared, x cubed. So just if you count yourself up, remainder's nothing. No x, x to the 1st, x to the 2nd, x to the 3rd. The answer should always have 1 less power in the original problem, so this is cubed, that's 4th, so that's what should happen. 1x cubed minus 2x squared plus 4x minus 8 plus 15 over x plus 2. Always put the remainder over the divisor. And notice that when I wrote it out, the 1's not relevant. If you just wrote x cubed, that's fine. If you want to write 1x cubed, that's fine. Positive 1x cubed is negative 2, so negative 2x squared. It's positive 4, so plus 4x. It's minus 8, so it's minus 8. It's positive 15, so it's plus 15 over x plus 2. Every one of these terms has to have signs in between them, so make sure that you account for those signs. I've seen people just put like x cubed, x squared, x, like that, and we'll just leave my answer looking like that. That's wrong because you'll have a plus sign out here and a plus sign out here. So be careful that when you finish your synthetic division, that you take an extra line on your paper and write out your answer just like that, accounting for every sign. So positive 4 puts a plus sign there. Positive 15 puts a plus sign there. Make sure those plus signs show up. Number 15, simplify, and we got negative powers, multiple letters, all that stuff going on. So job 1 is to make every term as best you can make it. This red term has too many x's and has a negative power. So this x cubed belongs on the bottom. Then I've got too many x's. Y is fine. I might put a first power on it. X should be to the 8th power on the bottom, and z is to the first power. Then I got a parentheses. Looking at this green term. The only issue with that is that negative power. Currently it's in whole number form, so 8 and x to the 8th and z are all numerator objects. Y to the first belongs in the denominator, again putting first powers on letters without powers. Then I got to minus all this stuff. Alright, so I got a negative power, I got too many z's, too many y's. So it is minus, so I put minus, 8 belongs on top. Now that's minus 8 to the first power, it's not a negative power, so be careful that 8's fine where it's at. So I don't really want to put a power on that, but that's what it is. Let's look at x. This right here belongs down here. On the bottom, x times x, we add the powers, we get x to the 8th. Y on top, y on bottom, y is bigger on top. 2 minus 1 is 1. And z on bottom and top, z is bigger on the bottom. 3 minus 2 is 1. So one of each letter, all powers positive. Get everything looking like that before you multiply. Then multiply. So if I do the red times the green, on top, I have 8 times x8, y first, z first, so nothing happens to those letters, you just get them all stuck together. On the bottom, I've got x times z times y, again they're all different, so x to the 8th, y to the first, z to the first. I know things cancel, don't worry about that right now, just get the answer. So top times top, get what you get, bottom times bottom, get what you get. Move on to the next multiplication. Positive times negative makes a negative. 8 times no other number makes 8. On top, y times y is y squared. On bottom, x times x, we get x to the 16th. We add powers. Z times z, we add powers, we get 2. Looking at this blue term, the blue term's perfect. 8's a number, doesn't reduce, because there's no number on the bottom. Y is the only y, x is the only x, z is the only z. That's perfect. The green term, we got too many x's, y's, and z's. So x8 over x8 cancels, y over y cancels, z over z cancels. If everything cancels, you have to write a 1. In this case, there's an 8 left over, so I'll write 8. That's it. So that's 8. All right? This fraction's on the second term, so minus, and then I make a fraction bar. 8y squared over x to the 16th z squared. Don't extend that fraction bar beyond that minus sign. This fraction became a non-fraction. Allow that to be a whole number. That's your final answer. You can't do anything else beyond that. This has letters, that doesn't. Subtraction's illegal. So that's the best you can possibly do to that problem. Stop there.